Right, this is a lecture on single variable Taylor series. It was requested by Queensland, UK, because I haven't got one up. Right, first off, definition. When you see something like this, which is a T, which is standing for Taylor series, the n at the bottom is the number of powers of x you want to get to. F of x is your function, and c is the value at which you want it all to be evaluated. Okay, so if we just look here, we've got, this is how you find the Taylor series of a single variable. So as we can see, f of x, not xy, no others than that. So we have f of c, which is our value we want, plus the derivative, f dash of c over 1 factorial times x minus c, plus derivative again, so double derivative of c over 2 factorial times x minus c squared, and so on. And this is actually the sum from n equals 0 to infinity of n factorial f nth derivative evaluated at c times x minus c to the n. Now we've got two examples. Right, first find t2, so we only want up to x squared, of log 1 minus x evaluated at 0. So first we want the derivative of, well, first we're going to have log, and we're going to evaluate it at 0, so log of 1, which is 0. Next we want to find the derivative, which is minus 1 over 1 minus x. You should know that. Yeah? And then evaluate that at 0 as well. We're evaluating all at 0. And that will be minus 1 over 1. Then we want the derivative again, which will be minus 1 over 1 minus x squared, because the power of here of minus 1 will move out, making it a plus 1. But you also have to find the derivative of this bracket, which is minus 1, so that moves out again, so keeping it minus 1. And we find the value here, which is minus 1 again. Now, as we've done, we've found the second derivative, which is the 2 here, so that finds how far we go to. Now we just want to substitute it in to our formula here and get our values. So we have the first one on its own, which will be 0, minus 1 times x minus 0, which is x minus x, and that's over 1 factorial, and this one's 1 over 2 factorial, which is a half, times our minus 1 times x minus 0 squared, which is x squared. Now this example's a bit trickier because it's asking for t to the n, so it's asking for a summation. It wants you to find a formula so you can get up to as many as you want. So we have cosine x as our function, and pi this time at the point we want to evaluate everything. So the first one, we have cosine x, f of pi is minus 1. Now we're not going to do this for all of them because there's n, but we're just trying to look for a pattern. So here we have minus sine x, and that's 0, minus cos x, which is 1 this time, instead of minus 1, and it'll go to 0, and then there'll be a pattern, so next it'll go to minus 1, then 0, then 1, then 0, then minus 1, and so on. And what we want to do is first we should write out as many as we can of the Taylor series, which we've done here. If we just ignore the bottom, yeah, you can see that. We have minus 1 plus, I've put them in anyway, 0 times x minus pi plus 1 over 2 factorial times x minus pi squared plus 0 times x minus c cubed minus 1 over 4 factorial x minus pi to the 4. And as you can see anyway, this term and this term are non-existent. Now what we want to do is we want to look for a pattern. So, well, our first term is minus 1. Our second term is 1 over 2 factorial times x minus pi squared. And if you notice, they're going up these powers on here. Sorry, there's no power there, there's 2 there, there's 4 there. It's going up in terms of 2. So we can put 2 to the n, because if we have n is 0, then this whole bracket here will go to 1. So we have -1, and this part I'll explain in a minute. N is 2, we'll get to the power of 2. N is 1, sorry. N is 2, we'll get to the power of 4. So this is getting all our terms that are actually included. So we're just ignoring these ones. Next, we can have a look at these. This is over 2 factorial over 4 factorial. So it's going from 1 factorial to 4. It's going up in 2s. So again, we can put 2n factorial. This is, you have to do a bit of trial in thinking about how all this comes together. And this one, what I've done, at first I tried -1 to the n, but obviously with n is 0, that all goes to 1, so we want a minus there, so I just put that in as a trial. And I did put an n is 2, but I tried that and that didn't work, so I just kept it as an n. And if we have it to 0, that'll go to -1. If we have it as 1, then this will go to -1 times minus, which will be a plus. And this one, again, is n is 2, so -1 squared, which is 1, with the minus, making it minus there. So that's the summation. Hope you can see that.